Well, good morning, good afternoon, and good evening, everyone who's joining this webinar from around the world. Delighted to say we have a phenomenal panel with us today who are going to be sharing their thoughts. And let me just pull their details up on the screen so you can see just who we have with us to share. If I can get it on the screen. Oh God, what am I doing? Sorry, there you go. Yes, so we have Patrick Bangert from Samsung, Maria Eira from the UN Center for Artificial Intelligence and Robotics, Julia Mossbridge, Executive Director of the Institute for Love and Time, David Wood, the Chair of London Futurists, and myself, CEO of Fast Future. And today our focus is really going to be on taking quite a broad exploration of the future of artificial intelligence, going from what's happening now in the commercial sector, in policing and justice, to looking at how the technology might play out over the next 5 to 10 years, and then really stretching out to look at the notions of what artificial general intelligence could mean, what is artificial general intelligence the answer to, and how do we make sure that it really delivers on all of humanity's needs rather than those of a particular subset. So it's going to be a very rich discussion. What I would encourage you all to do is, if you have questions, please put your questions in the Q&A box and then vote on the questions that you would most like to see answered. By all means, put comments in the chat box, but the panelists won't see those. So we won't be replying to anything in the chat box. And for those of you already here, if you see others putting questions in the chat box, please encourage them to post them into the Q&A. And we're also going to be doing a number of polls throughout the course of the session. So there'll be an opportunity for you to share your views that way. And as I say, to ask your questions via the Q&A. We won't be using the raise hands function, so please don't do that. But there'll be lots of opportunities throughout for you to ask questions of this incredible array of panelists. And to get things going, before we introduce the panel, I'm going to get a polling question up so that we can get a view of who's in the room. So this is just a chance for you to tell us who you are and what you do. And don't worry if your job title doesn't match exactly any of these categories. Just pick one that helps us get a sense of who's listening. We're going to go around and have each of the panelists in turn just take 30 seconds to introduce themselves. So I'm going to go around clockwise on my screen. So let's start with you, Patrick.
Hi, hello, my name is Patrick, and I'm the VP for Artificial Intelligence at Samsung. Most of you will know Samsung as a producer of mobile phones and laptops and TV screens, but the company does do many more things than that. Among others, we produce software on various applications of artificial intelligence, both on the side of creating machine learning models, as well as on the side of actually making the models themselves and deploying them in scale.
Okay, next, let's go to Maria.
Hello, I'm Maria. It's a pleasure to participate in this webinar. So I'm a research analyst in the Center for AI and Robotics of United Nations. My background is in biomedical engineering, but I later specialized in cognitive science and artificial intelligence. And so right now I'm working in this Center for AI and Robotics, whose main objective is to work on the use of AI for crime and justice.
And for those of you who are expecting Irakli, Maria's boss, unfortunately he had to drop out at the last minute. So Maria has very kindly agreed to step in, but I'm sure is going to cover very similar topics and be just as interesting and informative as Irakli promised to be.
I'll do my best.
Thank you, Maria. David.
Hi, my name's David Wood. In my professional career, I spent 25 years in the mobile computing and smartphone industry when I was responsible for large, complex pieces of software inside operating systems. So I saw what's involved in the progress of complicated software with unpredictable consequences. More recently, I've been working as a full-time futurist, helping people to think about the future.
Excellent. And Julia.
My background's in cognitive neuroscience and technology development, and my focus is on teaching and learning about love and time and what technology we can use to help scale ideas about future prediction and experiences of future prediction, as well as experiences and ideas about unconditional love.
And I'm Rohit Talwar, CEO of Fast Future. I speak, research, consult, and publish about the future as my day job. And since the pandemic started, we've built this series of webinars designed to take ideas and content and expertise from around the world to the broadest possible audience. I'm delighted with the panel we've assembled today. And let's just have a look at who's identified as being in the room. Not everyone has voted, but I think there's enough there to give us a feel. So it looks like we have around about 60% of the room are here because they're thinking about AI, or they're in government, or they have general interest, and about 40% seem to be more active in the field of AI, which is a very nice mix. I think that will give us a lot of interesting perspectives and hopefully a very rich dialogue over the course of the session. So just a reminder, there's a number of people joined since I welcomed everyone. Thank you all for joining us. And what I would encourage you to do is, if you have questions, put your questions in the box marked Q&A at the bottom of the screen, and then vote for the questions in there that you'd most like to see answered. If you have just general comments to each other, by all means put those in the chat box, but we can't guarantee that the panelists themselves will see them, as we'll all be focusing on each other in the Q&A. And I'm going to start us off with just a little scene setter, really, of a presentation about AI and where do we see it evolving to in the coming years. So we've already, sorry, wrong slide deck there that I'm about to put up. Sorry, just give me a second. Sorry, bear with me. Those of you who do our shows regularly, our events regularly, will know that I can be technically challenged at times. So just to go back, I also want to thank our sponsors for these webinars, UiPath, who are specialists in the field of applying robotic process automation to a range of tasks across a range of industries. And I think when you signed up, you had the opportunity to ask for more information on them, and there's contact information there, and we'll send that information out again after the event if you're interested in learning more about UiPath and their capabilities. So to get us going, I'm just going to do a short presentation about where I see AI right now. I think if we look across the piece, what we see is that when we strip away all the different language and descriptions, there seem to be three broad types of application going on. The first is where we're using whatever people are calling AI, whether that's machine learning, expert systems, chatbots, or whatever, to augment the work of humans. The classic application is in medical diagnosis, where no doctor could possibly look through all of the different pieces of research and cases on record for when they're assisting a patient with cancer. But by being able to look at all of that history of other patients across the web, the tools are providing them with a huge amount of decision support about the type of cancer it might be, the type of treatment regime, and then the doctor can then use their own expertise, their own judgment and experience to make a recommendation to that patient about what they believe the situation is and what they think the right care path is. The second is where we're able to now do things at a speed that were just previously unimaginable. So we see a lot of applications similar to the ones in the accounting world, where transactions that used to take 16 hours to do, compiling particular calculations on a client balance sheet, we now have AI applications doing that in 4 seconds. And we see a lot of those kinds of applications, the kinds of applications that are responding to tens of thousands of customer inquiries through chatbots and advisors at speed. And finally, doing things on a scale that humans simply couldn't do. So for example, a lot of the visual processing and language processing applications are in that kind of category. The classic one for me is still during the Football World Cup in Russia, when the Russian authorities used facial recognition and AI interpretation to identify people of interest in the crowd, whether it was potential hooligans or other security threats. If they identified someone going to a game who looked like they shouldn't be there, a police officer was notified to intercept them and hold them until the game was over. And as we know, although there were a lot of concerns about potential incidents during the World Cup, none actually materialized. And it's that kind of collection of applications, I think, that are dominant right now. Augmenting the work of humans, doing things at a speed, particularly in financial markets and high volume processing, and then doing things on a scale which humans couldn't imagine. And most of what I see today seems to fall under one of those categories. What we also know is that we were starting to understand prior to the pandemic that there were sort of 7 stages in AI's development, and I'll talk about those in a second. And what it feels like is that certainly some of these are being accelerated now. The investment in some of these, the desire to deploy some of these is really being accelerated. And for us, those 7 stages really are, firstly, the expert and rule-based systems that have been around for 20+ years doing mortgage applications, determining whether you could have a loan, all sorts of routine decision-making applications. And more recently, we've seen that kind of technology being applied in robotic process automation to enable people to actually write the rule scripts to automate their own jobs. And more of that kind of RPA or hyper-automation, as it's called, being rolled out quite readily. And now we've got to the point where people don't even know they're using it as a customer or even necessarily that they're using it as an employee in the workplace. The second stage, which has really seen a boost in the last few years, are the applications where the algorithm has some awareness of the context in which it's operating in an algorithmic sense, and some retention of information, of the answers that have been provided before, of the answers it has then generated to new inquiries as a result of additional human input. And that's in areas like chatbots and robo-advisors. And those are now quite commonplace. And certainly, I think Patrick's going to talk more about that and how this is still one of the main areas where we're seeing machine learning in particular being applied. The third sort of stage is where we move to AI having human level or better mastery of a particular task. And I think the public awareness of this first rose with AlphaGo, which was a machine learning application developed by Google's DeepMind to play Go, potentially the most complicated board game in the world with billions of possible move combinations. It took on the world Go champion, Lee Sedol, a 7th Dan Go champion, and beat him by 4 games to 1. AlphaGo was trained by humans so that when it made mistakes, it was guided and nudged. Then they created AlphaGo Zero, which was effectively allowed to train itself and work out its own strategy for playing the game. It took on AlphaGo, beat AlphaGo by 100 games to 0, and really started to get us thinking about the potential for AI to be used in all sorts of applications where it could replicate or outperform a human in a single domain. Had we then tried to train those applications to do other tasks like medical diagnosis or logistics planning, its performance would have declined with the technology at the time. But certainly a lot of what we see going on now in those kind of domain-specific applications is using this kind of technology. The next level is what some people argue we're starting to see, others say might be 5 years away, others say maybe 2, but it's certainly being accelerated, which is machines that algorithms that effectively have built into them some sense of how humans think, some sense of how other people make decisions, but also some sense of how their own logic works. So they have some capacity for reasoning, and we're seeing more and more of those. And many would argue that that effectively is the nature of the technology we see in things like autonomous vehicles and all sorts of autonomous devices. Real reasoning machines with that kind of deep theory of mind, I think, are again on the 2 to 5 year horizon. The next is really what many would say is the holy grail of artificial intelligence, which is to create artificial general intelligence, which is self-aware, either algorithmically or genuinely, and I don't know how we'll tell the difference in many cases, but maybe we will, but is capable of reasoning, of thinking, of performing human level tasks in a number of domains. Some people say we're already seeing that in some of the applications coming to market. I think within 5 years, we'll be seeing things that are as smart as 80% of humans 80% of the time, but it won't be true AGI. The argument rages, and David, I think we'll talk more about this, and Julia too, but some are saying it's a 10-year horizon. Others are saying, well, we may never be able to do it because we won't be able to fully replicate human consciousness, and also things like the intelligence in our body and our organs that is also part of human intelligence, that these are things that we just might never be able to capture. The debate is raging, but certainly there's a huge focus in the AI research community on advancing AGI right now. And then there's this next stage, which is this idea that if we create AGI, then it will be a natural evolution to get to superintelligence, where the AI is effectively generating itself and generating algorithms that are smarter than humans, able to solve problems that we've previously found intractable. You know, how do we solve world hunger and by resolving problems in the food chain? So we waste about 40% of all our fresh food globally. If we could harness that and solve that problem and then redistribute it to those in hunger, we could effectively wipe out world hunger. So could we create new solutions to global conflict resolution, managing the environment, all of those kinds of things? Could superintelligence put us on that path? And then finally, and many people are saying, well, that will come 5 to 10 years after AGI. And then there's this notion made very popular by Ray Kurzweil, chief engineer at Google, who talks about the singularity, that point where we've created superintelligence that then works how to network our brains, how to connect our brains so we can share our ideas, network our dreams, and share the collective brain power that we have with AI to really take us to a kind of almost transcendent level of existence. And that then opens the door to the possibility of things existing entirely in silicon, but living, or in some other substrate, but living in our world and playing just as active a role as carbon-based life forms. So those are the 7 stages, and Kurzweil has this target date of 2045 for this. Again, there's huge debate raging, but those 7 stages, I think, give us a sense of kind of where AI might go and what people are aiming at over time. So that's just my sort of opener for this. And while I get the panel's responses to that, I'm going to pop up a polling question in relation to that, really to allow you all to express your view as to where do you think we'll get to on those, out of those 7 areas of development in the next 10 years. And you can vote for more than one, you can pick more than one. But while we're doing that, let's just go around the panel and take everyone's reflections. And let's start with you, Julia. Let's start from the person who spoke last. Any short reflections on what you heard from me?
Yeah, I think we don't know what we mean by, we don't really have agreement on what we mean by singularity or transcendence. So I think some people will think we will have gotten there within 10 years and other people will argue that we haven't. I think the same thing is true for superintelligence. We don't really know what those rules are. For theory of mind, I think we're kind of bad at really agreeing on that. So I think that the real problem ends up being people agreeing on what the actual outcome measures are that would indicate what stage we're at. And I think that's going to be the underlying issue that we have to solve in the next 10 years is human understanding of what we're creating.
Great. Patrick, let's take your view next.
Yeah, I think this is a very interesting debate. I agree with Julia that, of course, it comes down to defining what you mean by this. even a bit more well-defined as the so-called Turing test, which was defined decades ago by Alan Turing, who came up with a test on how a human being would be able to judge whether or not a computer program is intelligent or not. I think even that definition is open to interpretation quite a bit. In that context, I recently read Dan Brown's novel Origin. It's a very good novel in its own right, but it brings up an interesting idea that effectively humanity is evolving to a new, what he calls species, basically the combination of my normal human body plus a smartphone extension, which effectively gives me a little bit of a superpower to do various things that without the smartphone I simply wasn't able to do before. And this combination is better at many tasks, mind you, not better ethically. It's better at many tasks than the phone on its own and then the human on its own. So in some sense, if we take this general intelligence a little bit broader and say that it mustn't only be the computer program, but a combination of human and computer program, then it's a different debate altogether, and we may have something like this already.
Thank you, Patrick. Maria.
Yes, so of course I agree that the definition will also play a really important role, because if we think about machines that are smarter than humans, we will see a lot of them that are making a lot of tasks much better than us, a lot of computations and so on. But when we think about a general intelligence system that can perform several tasks, so it's not a narrow anymore, so it can have different tasks and adapt to a different task, we can think about having access to different databases. So it's basically going to Google and search for a new database that can solve a new problem. But I think we are still far from having emotions and conscience and having human characteristics that I'm not sure how to program them and how to replicate them in machines.
Great, thank you. David.
So thanks, Rohit, for setting out a very interesting and helpful spectrum of possibilities. And as you know, people have different definitions. I think most people in the AGI community will disagree with you that AGI means self-aware. Self-awareness is complicated. All programs after a certain sophistication are automatically self-aware in that they can include themselves in their modeling. Whether there's a consciousness in there is a separate question. And most people will say that we could have systems that are as intelligent in humans in every way without them having any consciousness. And that's the most likely outcome. And that's the one we should focus on, because when we do have such systems, it changes everything. There will be systems who, as I said, probably won't be conscious or self-aware, but they will be better than humans, better than any groups in humans in solving tasks, in figuring out how to address problems and to pursue and achieve their own goals. We can come back to this discussion. I'm not sure it's a good idea to design computers that are self-aware or conscious, but certainly we have to anticipate the issues before it happens.
Well, excellent, thank you. And we've already got some interesting contention there and different perspectives coming from the panel. Just before I put up the polling results, can I plead with the participants, if you've got general comments, put them in the chat box. If you've got questions that you need the panel to answer, then put them in the Q&A. If you put general comments in the Q&A, we're just going to ignore them because we're not going to answer them. Please make it a question, and a question generally ends with a question mark at the end. So hopefully everyone's kind of got the rules of grammar on that. So let's just have a look at where people think we're going to be on this. Interesting that less than 60%, actually, or just under 60%, think that we'll have AI in widespread routine use by 2030, given that it's already spreading quite wildly. And about a third think we'll have some sort of self-aware AGI out there by that time, which is interesting. So that'll be interesting to see what comes out in the discussion as we go along as to the views on that. And people's views as to whether we can have something that's artificially generally intelligent without consciousness or without self-awareness. I think that's one of the interesting areas for exploration. So let's stop on my part of this, and I'm going to move on now and open the floor to Patrick to share his opening thoughts for us, and what you'd like to explore in terms of particularly around the corporate use of AI and where you think that's going in the coming years.
Yeah, thank you, Rohit. So first of all, thank you for having me on this panel. As a mathematician and longtime machine learner, I try to put into context what we actually have. I try to be careful with my definitions. Seeing the future is a fantastic thing, but I personally don't know. I don't have the crystal ball. So in this panel, I will try to focus on the status quo. If you are worried, perhaps, about artificial intelligence taking over the world, I can say to you, please don't be worried, because it already has. If you use any modern technology, you go on the internet, Google, type in a search, the answer is produced by AI. If you go to Amazon and it tells you to buy a certain thing, the answer is produced by AI. If you bring up Netflix, it tells you what movies to watch, that's AI. If you visit a website of a manufacturer of cars or other goods, a window will pop up asking you if you have any questions about anything. That's a chatbot, it's AI. You are interacting with these systems multiple times every day of your life. And so artificial intelligence is there. It has basically taken over the world already in many, many functions, the vast majority of which you don't even see or consciously interact with. They are in the background in some function, or they are so seamlessly integrated in your daily experience that you don't even identify that this is in fact an AI system. There are applications like the ones I've mentioned, which are effectively focused on automating something that could be done by a human being as well. There are other functions that do things that are novel. For instance, if you wear a smartwatch that measures your pulse, it will draw conclusions about what you're doing right now. Are you exercising? Are you sleeping? It counts your steps. It will tell you how many calories you're consuming. It'll give you information about how well you slept at night. These sorts of insights were, of course, not possible prior to some specialized AI algorithms that do this kind of thing. On a retail side, consumer behavior is being forecasted. And you might think, oh my goodness, can this retail company predict how I am going to behave, what I am going to buy? Well, no. But statistically speaking, over the size of a country, tens of millions of consumers, yes, it can. Human behavior is numerically describable in large numbers. And that becomes a science for the retail industry, the wholesale industry, if it wants to get certain products out there. For example, you know, how many shirts of a certain size do I need to store at the London branch versus the Manchester branch? AI will tell the company how to do that. So these systems are out there. And they do, in my opinion, or they are characterized, in my opinion, by three major factors. First of all, they are very narrow in their focus. They give a specific numerical answer to a specific numerical question. What's my resting heart rate? Did I sleep well? How many shirts should I stock in the London branch? What movie am I going to recommend to the person to watch next? These are very, very specific questions. Even on the chatbot level, natural language processing, it's what is the right response in a sentence to the sentence that the human being has input. So narrow focus is the first characterization. The second characterization, in my opinion, is that they are very brittle. brittle means that if I give an input to the system that is different from the inputs that have been used to make that system, only by a little bit, I can expect the result to be significantly different from the result that I expect. For example, just last week, we have had a natural language system being released by a major IT company here in the Silicon Valley, which is supposed to raise the natural language processing to a new level. If you ask it questions like, I have 3 apples and 4 pears, how many fruits do I have? The answer is 17. Now, it is absolutely remarkable that this AI system recognizes that I'm expecting a numerical response. Yes, I'm asking a question about how many and I'm expecting a number. However, the system gives me the wrong number. So you think, okay, an AI system should be able to add 3 and 4 and come up with 7. Yes, obviously, it doesn't need to be AI to do that. But the system, while it characterizes language correctly, it fails to grasp the actual context. So how this is done is by machine learning. The language is represented statistically. Words, confluences of 2 words, confluences of 3 words, and so on are represented statistically speaking, and a statistical response is provided back to you, which in this case grasps correctly. You're expecting a number, it just gets the value wrong. So this is brittleness. If you supply it with a slightly different input, you get a vastly different output. The third aspect is the aspect of accuracy. For the vast majority of AI applications that are currently deployed, accuracy doesn't matter very much. So if I recommend a movie to watch, if you think that movie is bad, well, sorry, but the damage done is minimal. If I recommend a shirt for you to buy, the damage done is minimal. There are certain healthcare aspects, of course, where I'm trying to detect, do you have lung cancer or not? In that case, accuracy, I hope, would be high. However, those kinds of outputs are still being checked by human experts. Nothing is being done purely on the basis of an AI diagnosis in healthcare. For many systems where accuracy would be a critical requirement, AI is currently, as far as I'm aware, not so much deployed. There are exceptions, but they are few. So those are the 3 characteristics that the status quo currently has. So the narrow focus, the brittleness of input-output, and the demand of accuracy, which is fairly low. Now, if you look at the business side of things, where's money being spent? Obviously, businesses make AI to earn money. To make those AIs, you have to invest money. So where are investors putting their money? Currently, those investments are going into 3 areas. The biggest is autonomous driving. I would say that significantly more than half, maybe even over 60% of the financial investment into AI, machine learning, and anything related to that is in the context of making cars drive themselves. Much of that is image-based, video-based analysis. The second is healthcare. And in healthcare, the applications are extremely specific. Again, it's not just detecting cancer. No, it's detecting specific forms of cancer. There's AI that detects breast cancer. There's AI that detects colon cancer, and so on and so forth. And the third area is finance, obviously, because our boys at Wall Street would like to forecast when they can make their next millions. Again, a very specific application of AI. All of that is done by a school of thought that's been called the connectionists. That is those people who make neural networks. They're called connectionists because of these diagrams that you see with neural networks where you have nodes and nodes in various levels and you connect them with lines. Ultimately, it's a matrix-based equation. It's different from other AI systems that are based on reasoning and logic, like expert systems and so on. And recently, those areas of connectionists, so neural networks, convolutional neural networks and such, have been extremely successful at these specific applications, but they are found to suffer from not knowing anything about the world. So my personal opinion about the near-term future of AI as applied to real life is that I think we need to somehow unify the connectionist approach of neural networks with the, let's say, older and somewhat disregarded aspect of AI, which is based on logical reasoning and systems of that sort, which represent the world in some sort of fashion, so that the AI can gain what one might call understanding of the context of what it's reasoning about. And I think that will drive the field forward. That would gain us broader AI applications that are less brittle, that might even gain accuracy. I would foresee that if people were prepared to invest a significant amount of effort and money into that unification, that could be done within 10 years from now. However, I should say that I do not see anyone currently at this time putting significant amounts of resources and money into that.
Thank you, Patrick. I'm very conscious that we've kind of run over the 8 minutes significantly. So I want to make sure that we kind of manage our time well. So what I'm going to do is, you can bring other thoughts in later on. Let's launch the polling question you had, which is around what do people see as the most important needs when delivering commercial AI systems? And while we're doing that, let's bring the other panel members in to reflect on what they heard from you. And let's start with David.
So I agreed with everything I heard Patrick say. So I think it's a great introduction to the status of the industry and its issues. I was going to ask you about ways to solve the brittleness problem, and people are studying adversarial AIs and defenses against adversarial AIs in order to come up with better understanding. So a lot of interest in explainable AI systems. Do you think they have any chance of working by themselves, or is it necessary to do the combination that you mentioned of good old-fashioned AI with connectionism in order to comprehensively solve these adversarial and fragility issues?
I'm going to say, let's hold, Patrick, on your answers. Let's take the input from the other two panelists and then have you respond to those, because the similar questions have also come up from the participants. Julia, what was your take on what you heard?
Yeah, also agree. Also feel like, just from background from the way the brain evolved, is you do have hard coding. You have these areas where you actually have, this neuron does talk to that neuron, and that's the situation, and it doesn't talk to this other neuron over there. And you do have the connectionism over time. And so I really want to underscore that idea of, frankly, if we're trying to try to do something that's something like human intelligence, we ought to take a tip from evolution there.
Excellent. Maria?
Yeah, sure, totally agree. I think it's important to reinforce this idea that we are talking about matrices and systems that do not understand French and do not recognize a cat. It's basically numbers and the recombination of features that give a specific output, but for the machine, this output has no meaning. There's not a meaning that it has for us. So I think it's really interesting to demystify this idea that machines are already understanding the world, because we are not there yet.
Excellent. So Patrick, we also have a question from the participants, from Harsiman Singh, on this theme of explainable AI. So it'd be great to get some of your insights on, where are we with that? Where can we expect to be with explainable AI in the next couple of years? And is that the critical barrier to corporate adoption in terms of being able to justify how we reached a conclusion or made the choice we made about giving you a mortgage, or investing in a particular stock, or deciding what your treatment should be?
So thank you for all those questions. I'll try to be quick in my answer. So to David's question, yes, I do think that the brittleness problem can be solved in this way, although my take from real live data sets is that the problem is not in the AI, it's in the data set used to train the AI. Most of the time we have access to either not enough data, or in the case of many applications, we have a great deal of data, but it's mostly duplicates. So the interesting, informative data is missing many times. So I see the brittleness problem being a reflection of data issues. Adversarial networks, of course, they're fantastic because they specifically target weaknesses and expose them. So that's a very good thing to probe for this brittleness that you then have to solve. Julia, to your point, hard-coded in the brain, absolutely. When a human being is born, that baby is not a blank slate. Evolution, genetics, whatever, and I'm not an expert on this, has created the brain with a certain predefined structure in place. And generally AI systems do not do that. They start from a blank slate. And of course, with a vastly smaller blank slate than the number of neurons we have in our heads. There is, though, a little field called transfer learning, which starts from an already trained AI and, if you will, upgrades it with more training data. That is being done, and quite successfully so. So that is going very slightly in that direction, but most applications still start from a blank slate. To get to the explainable AI question of David and Mr. Singh, explainable AI is relatively new. The demands for it have been around for a long time, but serious attempts at doing it are relatively new. Of course, many applications don't need it. Again, recommender systems of what movie to watch doesn't matter. But of course, for ethically important decisions like you don't get a loan, people want an answer of why. And so an answer must be given. And in that case, yes, there are many ways of dealing with that. The real question in a computer program kind of sense is, how do you want that answer? How do we need to communicate that answer to the end customer? Saying that neuron 56 in layer 4 is responsible for the fact that your neural network ended up with a 1 instead of a 0 for the question, do you get a loan or not, is not helpful. That kind of answer, however, is an answer that we currently can give. We can blame it on a layer, we can blame it on a neuron. Coming up with a sentence in the English language that formulates this in a way that the consumer can say, oh yes, okay, I get it, I need to do this and that in my behavior. That is a challenge, and that depends on the individual use case. So I say explainable AI, basically, yes, we have it. But in order to come up with an explanation that makes sense, it's use case specific and therefore requires customization.
Thank you, Patrick. We're going to share the results of your poll and just get quick reflections from you so that we can then move on to Maria. Any surprises there in the results that you see on the screen?
I mean, I think this is great. Obviously, people say high accuracy is the greatest demand. I think that's accurate for many applications. Of course, as I've pointed out, for quite a few of the consumer applications, currently we don't think it's necessary. But I agree with many of the fields that are currently in development. Autonomous vehicles, obviously being the highest one, their accuracy will determine your survival, literally.
Right.
So indeed, that is good. High robustness, yes, we've been talking about the brittleness problem. So them being less brittle will definitely be great. I'm a little surprised at the language-based super outperforming image and numbers, but yeah, I think that's because language-based systems are, of course, more observable.
Okay, thank you. In the interest of time, I think we could literally spend the whole 2 hours just with you talking about some of these issues, but thank you. I think you've given us an excellent start. And now we're going to move on to Maria to talk us through some of the potential applications in policing and justice, but also some of the broader issues around governance and ethics that are raised by the technology. Maria, over to you.
Thank you. Yeah, indeed, I will dive into a much more specific application of AI. I brought some slides with me. I hope I can share the screen. Is everybody seeing it?
Yes, we can see that fine.
Okay. So as I said, I work for the Center of AI and Robotics of United Nations. The center is located in The Hague, and the main mission is to advance the understanding of AI for the academia, the privacy industry, and international organizations. We are focused on crime, justice, and peace, and the main objective is to promote public safety and reduce crime. As any powerful tool, artificial intelligence has this nature of a double-edged sword. So it can either be, it's both a source of promise and peril. And so artificial intelligence has holds the potential to help to achieve the Sustainable Development Goals defined by United Nations, and our center is focused on the SDG 16, which is related to peace, justice, and strong institutions. So our main aim is to use AI and robotics to enhance the national capabilities of law enforcement and the criminal justice systems that allows to reduce all forms of violence, promote the rule of law, combat all forms of organized crime, between others. Among the new opportunities that AI can bring for law enforcement, for example, AI can help combating online child sexual abuse. We can imagine an application with facial recognition that can identify the faces of the children in online content. For example, to detect financial transactions that can indicate a possibility of money laundering, or to increase privacy by using anonymization processes that can hide the identity of individuals that are recorded in surveillance systems. Although AI can bring enormous benefits for society, it can also bring new threats. Actually, we have here, for example, the digital, physical, and political threats, and we have some projects that we are working in each of these sectors. For example, in the digital threats, we have a project with Europol and the cybersecurity company to investigate the malicious uses of AI for cybercrime and cyber-enabled crimes. Within the physical threats, we also have a project with the United Nations Office for Counterterrorism, and we explore some possibilities, namely the combination of AI and robotics for terrorist purposes. We can imagine drones with facial recognition systems that can target specific individuals and deliver explosives and other scenarios. And finally, political threats. We are working on a project to study the spread of deep fakes. deepfakes are synthetic media generated by deep learning, sophisticated algorithms that basically generate fake videos of people saying things that they never said. And we can imagine scenarios of situations that we can undermine elections and even destroy the credibility of some politicians. Within the legitimate uses of AI, the use by law enforcement and other governmental entities can bring some concerns. For example, unjustifiable or disproportionate uses, we can imagine surveillance systems that violate the rights to privacy, bias in databases. So databases are collected by humans, and humans have inherent biases, which will naturally be reflected in this data. So if we then train artificial intelligence or machine learning algorithms in these databases, we will probably reflect this bias and increase discrimination in their outputs. And we can also assist to a growing digital divide between the countries that can benefit from this technology and the countries that cannot. And we can exacerbate these inequalities between the developed and the developing world. So following the recommendations of the United Nations Secretary General Antonio Guterres, we must acknowledge that this technology brings a lot of potential for society and opens new frontiers of human welfare, knowledge, and exploration. However, we must be careful, and we must guarantee that is not used to erode human rights, deepen inequality, or exacerbate existing discrimination. So we have here a complex problem, and we may try to address this complex situation through ethics and regulation. So the main message here it's that the use of artificial intelligence by law enforcement agencies should never undermine the fundamental principles of law and damage the public trust in law enforcement and governmental entities. So for that, the design, development, and deployment of this technology should respect these principles and follow some more specific and technical requirements of fairness, accountability, transparency, and explainability throughout their entire life cycle. So we have assisted to several initiatives and strategies that try to regulate the use of AI. They are coming from several countries, but also from some intergovernmental entities. And but we assist that these documents are somehow always too broad and are not domain specific. So in our case, we have a global platform with Interpol. This is one of the biggest projects of our center that brings law enforcement, the industry, and academia together in an annual meeting. We will have this November our third global meeting, which is concerned to the use of AI for law enforcement in a responsible manner. So after each one of these meetings, we launch a report. It's a full report that highlights the biggest findings and the key thoughts about these conferences. And
1 minute, Maria, to wrap up. 1 minute to wrap up.
Can I continue?
Yeah, 1 minute though. Can you wrap up in 1 minute?
Okay, sure. I'm finishing. This is last slide. So we are now we'll start developing a toolkit for the responsible use of AI by law enforcement, which departs from the guidelines, ethical guidelines, and regulations, in the sense which is a more practical oriented guidance on how this technology might be used in a responsible way. And we hope with this to stimulate the positive potential of AI. Thank you very much.
Thank you, Maria. Let's get everyone back on the screen, and also let's launch your polling question. Fascinating ideas in what you had to say. Let's see what people see as the priorities coming out of that. So this question is all about how do we ensure the future benefits of AI are shared amongst the many rather than just the few. And while we're doing that, let's take reactions from each of the panel in turn. Let's start with you, Julia.
So glad that your organization exists. Of course, there's questions about, you know, who oversees your organization and what the transparency is there, which I think is an important thing for your organization to communicate to the world. But yeah, great. Hope it all works out. I think I can't argue with any of the goals, so I'm happy about that.
Okay, David.
So I really liked the balance in what Maria was talking about. Too often various government institutes, EU bodies emphasize, here are all the things that could go wrong with AI. I was on a call the other day in which there was a 250-page report just listing all the things that could go wrong, without emphasizing that if we are slow in developing AI, we're missing out on many benefits. We could be curing many people's lives. So I really liked the balance in what Maria was saying. And for example, talking about bias, of course, AI is biased, but we humans are biased, and our biases are often hidden. Whereas, isn't it the case in AI that the biases can be more readily noticed and then fixed? And so, yes, there are real issues there, but I really like the positive framing of it rather than just the doom and gloom, which we sometimes hear.
Excellent. Yeah, I completely agree that the risk is that we spend so much time talking about all the risks that we don't think about how this can be harnessed for human benefit, and then what are the frameworks we put around it to achieve that, rather than just being paralyzed by the risks and writing continuous, as you say, 256-page reports on all the risks. That people get risk fatigue, I think, very quickly. I was on that call, and I remember being quite tired after about the first 10 slides and thinking, wow, this is just overwhelming. I need to read this on my own. I don't need it to be read to me. Patrick, what were your reflections on what Maria had to say?
So the risks definitely exist. However, with a technology like AI, somebody will develop it. So whether the UN or somebody else regulates it or not, these technologies exist. I'm sure everybody is aware that facial recognition is widespread in China, resulting in a social score, which has real impact on real people's individual lives. So these kinds of supervisory technologies are around already today, and I can only support the means to have a controlling body of some kind. Whether it's successful at truly controlling sovereign states is a different question. But I think it's a fantastic initiative by the UN, and you know, I'd like to support that in every way I can.
Excellent. Let's take, I'm going to combine a couple of questions that we've had. So one from Grace Cheney and one from Diane Edwards. And Diane says there are challenges of complexity through political, economic, and ethical and other human quirky behaviors that impact why we can't solve some of our big world problems. How do we think AI could overcome them? And then let's weave in Grace Cheney's question, which is, how is AI predicted to influence politics in the future? So let's start with you, Maria. How do you think we can use AI to overcome some of these complex problems that aren't technological, but that are to do with the interaction of all our systems, you know, political, economic, social?
Yeah, actually there is a really interesting recent study by Nature that does an exhaustive investigation of how can AI address each of the Sustainable Development Goals. And the conclusions are really interesting because they state that while it can basically benefit and help to achieve all sustainable development goals in each of their specific targets, they can also inhibit the achievement of the others. But the balance between the number that could help and the number that could inhibit, it's more than the double that could help. So I think it's a positive perspective on this, and our mandate is also to help the other UN agencies to achieve better results, even in their performance or in all their projects to use AI for the good, basically.
Thank you. Anyone else got a view on that, on the role of AI in politics, or how we use AI to overcome these complex systemic interactions between politics, economics, and ethics? Anyone else want to take a crack at that one?
Well, we should bear in mind that AI can make politics worse as well as making politics better. Just to go back on the doom and gloom, but it's a more balanced opinion. We already are seeing fake news, fake media distorting the workings of democracy. Personalized messages which know exactly which buttons to press in each of us to make us identify with things which previously we wouldn't have thought of identifying with. And so the biggest risks to the 2020 and subsequent elections are that the higher caliber of AI, dare I say it, will be deployed to make more people think they're voting for what they always wanted to vote for, but actually they've subtly been nudged in a different direction, which is another reason why we need to get ahead of this rather than just leave it up to the spy agencies and the other groups to deploy this technology.
Yes. Yeah,
sorry,
actually, in the deep fakes scenario, we have from some conclusions from our study already, and it's interesting to see that these deep fakes, these videos that are computer generated, have a really short time effect, because if we are talking about a famous politician, there will always someone that will come and say that this video is fake. So the actually impact of these fake videos, it's quite short. Of course, it will have an impact if it's on the last day of elections, but somehow there are ways of there. Even AI can help detecting fake videos. So I think it's we are going on the right direction also.
I would push back very quickly. Sometimes people see something and then they're told it was a fake, but still it's influenced them and the damage has been done. And at a different level of their mind, they've changed their opinion.
Yeah, I think we probably need to find better ways of using AI in the filtration process before a video goes live than once it's out there, because it's, you know, the genie's out of the bottle effectively. Patrick, Julia, did either of you want to say anything on this issue of AI's role in this intersection between politics, economy, and society?
Well, I think our communication is increasingly shaped by social media and other internet content, and it's of course AI that selects what you see. Most of these selection recommender engines are based on your past behavior, so you will be presented with opinions that you have previously agreed with, which tends to segregate political opinions further and further into different groups. If I have a good profile on the internet, I will never see the opinions of opposing groups. Therefore, I will never have the chance to think through them, and I will just be in people who say yes to my own opinion. And that's a danger in itself. My horizon is being narrowed artificially by AI that is trying to serve me.
Thank you. Thank you. Yeah, I think that's a very valid point. So Maria, let's just close this section with your reflections on your poll. You should be able to see the results on the screen now.
Yeah. So people believe there should be a regulation through an international organism, and with a quite similar results, a more scientific perspective, which makes sense because this is not just politics. It must involve the people, the experts, and as well some privacy and we can see some international commercial rules as well. So I think it's exactly this. We need a combination of different actors, different stakeholders, so that we can achieve the best for the use of AI. Exactly.
I'm interested to see that only 40% or less than 40% are in favor of some sort of commercial regulation, which is interesting because the potential power involved. Again, maybe we can come back to that later on to discuss that. I'm going to end this session there. Thank you so much, Maria. Fascinating presentation, and it's opened up a whole other dimension of the dialogue. Before we move to David, I just want to do a little reminder to everyone. If you have questions that you want the panel to answer, and there are a lot of them already, please put them in the box that says Q&A. And then to all of you, please vote on the questions you'd most like to see answered. We're not going to be able to answer them all, but the ones that get the most votes will rise to the top, and those we're most likely to answer. I've seen a few people putting their hands up. I'm afraid the nature of the format we have doesn't allow us to go off to people to make verbal contributions. So if you have a question, please put it in the Q&A. If you have just a general comment or you want to discuss with the other participants, then feel free to just keep posting in the chat box. With that, I'm going to move on now to David Wood, who's going to share with us some of his thoughts around what we see as likely developments, or what he sees as likely developments in the next 5 to 10 years. David, over to you.
Thank you so much, Rohit. Let me address this question. How will AI be different in 5 to 10 years' time? Some people imagine it'll be more or less the same, an extension of today. I want to point out a number of ways in which it could be very different from today. And I'll start my exercise in foresight with an exercise in hindsight. Bit simple, but I think at a certain level it's true that if you'd asked people in 2010 to predict AI in 5 or 10 years' time from then, most of them wouldn't have really anticipated what would happen. In 2010, expert systems were all the rage, with rules handcrafted painstakingly by experts reflecting human views. There was lots of progress. There was some machine learning. There was probabilistic reasoning. But people who knew about neural networks were, on the whole, skeptical about them having any real significance, in part for empirical reasons. There wasn't much progress except in a few narrow applications, and in part for theoretical reasons. There were lots of people like the giants of the first generation of artificial intelligence, Marvin Minsky, Seymour Papert, who had apparently proven that neural networks of various sorts could never amount to much. But nowadays we look back and say, oh yes, good old-fashioned AI. And what happened was an explosion in the applications of deep neural networks, machine learning, in which the systems weren't handcrafted by humans, but machines themselves found the right parameters to put in place. Let me just move the screen out of the way so I can continue here. There has been unexpectedly swift progress in image recognition, language translation, speech recognition, driven by what made the difference. Turns out tipping points were reached in labeled big data, improved hardware that could do lots of computations in parallel, such as GPUs helped. And yes, there were some improvements in the algorithms and in the design of the various layers. So what I'm going to look at is the possibility that the same will happen again, that there could be other significant changes, quite revolutionary, in the next 5 to 10 years. And we'll look back at today's neural networks and say, ah, yes, do you remember these good old-fashioned neural networks? Changes like this need to be enabled by a supply of ideas and a supply of people to work on them, a supply of financial investment. I'll come to the ideas in a minute, but I'll just stop for a second on the demand for a better AI. This is no longer just a few scientists or a few philosophers or a few academics trying to figure out how to do better AI. There are huge profits being made already by the leaders in applying AI, And there is every industry who is seeking to find clever new ways to do better AI, including the stock traders, healthcare and medicine, gaming and entertainment, engineering and science, including engineering of self-driving cars. And by the way, it's not just a competition between commercial pressures, there's competition between the political powers in the world. So there's all kinds of demand for better AI, and I'm going to concentrate on the next 4.5 minutes on a supply of ideas. The first of these 12 ideas is even bigger sets of data. As Patrick said, one of the limitations of many neural AIs is the data isn't sufficiently good. Well, now we can use AI to synthesize and generate data from which other AIs can learn. That may sound paradoxical, but it can be very useful. We can also have baby or narrow AIs cleaning up data, which is then fed to a deep neural network to help it progress. I foresee coming out of this not just quantitative changes, but possibly qualitative changes too. But then instead of just looking at huge data, we should be looking at learning from small data, as a young child can do. As the brain has already been adapted by its own very large learning progress, so that a young child can learn the difference between a cat and a dog without looking at a million pictures of cats and dogs first. The key word here is already been mentioned by Patrick. It is the idea of transfer learning, that systems which are trained in one environment can, if done right, enable much faster progress in other fields, also sometimes referred to in part as unsupervised learning. Another example, which has long been spoken about, which has never happened yet, is that systems could learn by themselves by reading all the information that exists online, not just finding out how to translate it from one language to another, but increasingly they could understand it. If there was a small seed of data which was handcrafted, then this could grow in iterative cycles. This has never happened yet. Every time it's been tried, the systems grow unstable and false conclusions are inferred by the system and it ends up not understanding. But one day it may get it right. We should also talk about adversarial networks. There has been remarkable progress in the last few years in generative adversarial networks, in which two different networks are, in a sense, in an arms race with each other. One of them is trying to generate new pictures, and the other is trying to find the novel ones from the existing ones. And it has led to remarkable steps forward, which are still exploding in their applicability in the last few years. That is one way in which AI might learn from what happens in nature. After all, many of the great progress in nature has happened by arms races and evolution. But there are other ideas in which AI could learn from what's happened in nature. Genetic algorithms have been spoken about for many decades. They haven't amounted to anything remarkable. But then again, neural networks didn't amount to anything remarkable until the breakthroughs happened. So that might be another source of great new insight. And then there's learning from the human brain. And this can happen at two levels. And it is noteworthy that many of the large AI companies have hired lots of people with PhDs in neuroscience. And so there could be new ideas in the software, a bit like neural networks were inspired by a simple model of what might be happening inside the brain. Well, as we understand the brain better, we can have new models better than the existing neural networks. And we might also learn from the hardware of the brain with the neuromorphic computing. And by the way, the better AI gets, the more we can understand and analyze the brain, and therefore the more chance of these big leaps forwards. Other changes in hardware might include quantum computing, which I noticed there has been questions about. The future of quantum computing is very hard to predict, but it might let some algorithms run faster than before. More interestingly, it enables new kinds of algorithms which are never feasible before. So AI won't run entirely on quantum computers, but it might run partly on quantum computers. That leads us to the field of computers that simulate emotions, artificial emotional intelligence, in which computers recognize emotional displays in humans and can manifest emotions apparently of their own. These aren't real emotions, but there is another smaller field of research into sentient computing, which tries to design consciousness in. So this wouldn't be artificial emotional intelligence, it would be in a sense real emotional intelligence. The last two examples are, first of all, the Book of Why by Judea Perel, who has argued that the biggest breakthroughs in AI will come by understanding not just patterns of correlation, but causal implications underneath. The way that we humans often see more than just patterns, we infer that this is causing that. And last on the list is emergence of grand intelligence from networks of smaller, simpler intelligence, as is being promoted and researched avidly by SingularityNet. So what are the timescales for these major breakthroughs, and what will the implications of each of them be? Nobody can say, because they haven't happened yet. But I do urge people to keep an open mind and to beware any dogmatic skeptics who say none of this can ever happen for 10 years or 50 years or 100 years. Bear in mind that experts often get caught in their own paradigm of thinking. Instead, we should be prepared for a single breakthrough unexpectedly, possibly having much larger implications, a bit like the implications of quantum mechanics suddenly in the 1920s and 30s solved many branches of physics, and a bit like the breakthroughs in 2012 in neural networks opened unexpectedly many fields. So we have to prepare now for the possibility of large breakthroughs and for the possibilities of potential bad consequences too. If the consequences of today's AI can be bad, the consequences of this new, more powerful AI could be even larger. So we have to consider the anticipatory governance and ensure there's sufficient research into the potential problems arising.
Thank you, David. Let's just take a moment to breathe and reflect after that tour de force of 12 fields in 11 minutes. And let's get your polling question up.
10 minutes.
Well, it's 11 on my clock, David, and I'm in charge. Anyway, let's get this up. And whilst people are voting on your question about when we think there's a 20% chance of AI existing, let's get everyone else up on screen and just take reflections on what you heard from David. Maybe just pick on one or two aspects of it rather than trying to comment on all 12. Julia, would you like to start? What's your
Sure. Yeah, I'm a person also who spends most of my time thinking about the future and trying to look at the present day from a future perspective, and what are we grateful for that we learned and the breakthroughs that we found now. I thought your list was beautiful. I guess I would sort of disagree with the timeline. In the late 80s, I was involved in genetic algorithms, neural networks, and in college. So there was a group of people who were sort of anti-Minsky acolytes. But yeah, you're right. It didn't get really mainstream until at least the aughts. But I just love the way that you presented all the possible ideas that we know about now. And then I just want to say to everyone, keep in mind that there are things on that list that you can't even think of now that are going to be major game changers. So.
Absolutely. Patrick, what's your take?
Yeah, beautiful presentation. Those 12 aspects are really great. Of course, there are people working on each one of those 12 aspects already. So just in my company at Samsung, we're working on the first 6 actively in the commercial environment. I think the most crucial of those is the small data piece. Because in very many scenarios, the knee-jerk reaction of get more data simply isn't possible. We're limited by the world to a certain size of data. That's it, that's all you get. And having better algorithms that can extract the information in those small data sets, that is going to be an absolute game changer, and lots of people are working on that.
Thank you. I agree. I think there's also a risk here of the arms race between the corporations really, when they pick the particular set of technologies they want to focus on, maybe that crushes some of the other more promising fields that they just don't get access to funding and airtime. But I guess that's always been true in science, you know, and that this wouldn't be the first time that that's happened. But the fear is that we end up starving particular fields of research simply because whoever the major players are with the investment choose not to play in that space because they don't. That's the one.
Quick reaction, Rohit. That's true in academia too, because academic research is controlled by third-party funding.
Exactly. No, I mean, this is what I was talking about. So, you know, the universities are funded by corporates again quite often, but you know, hopefully that with so much money being targeted, you know, most of the promising fields will get some nourishment. Maria, what's your take on what you heard?
Yes, it's a really interesting presentation, and yeah, it makes us think that even if we are skeptical about these general intelligence systems, we may think that not even 10 years ago we will not believe that we will be able to recognize objects as we do it today. So yes, I think we have to be open for another breakthrough that may happen in the next years.
Great. So David, let's take some of the questions that have come in from the audience now. And there's one that's been here for a while now from Martin Longbucco, which is, what is your opinion about AI and quantum computing combination? And this is for any of the panel as well to jump in on. We've got a few minutes to answer some questions. Where do we see that relationship between AI and quantum developing, and what could it deliver for us?
I don't believe that anytime soon there will be a quantum computer by itself that's capable of doing any significant large AI computation, but there may be a bit like a QPU is an adjunct to a main system, a bit like a GPU was originally an adjunct to a PC. It did some of the calculations. So over time, we may see QPUs having a more important role generally in computing. And then it is possible that just as GPUs enabled parallel processing, which suddenly made the matrix multiplications that are key in deep neural networks, made them much more feasible, it may be that the QPUs could do some calculations which enable a new approach to AI. In terms of timescales, all bets are off, because although there is an increase in the number of qubits available in quantum computing, it's not the number of qubits that's all important, because there is more and more errors as there are more qubits. And so it's hard to know how the error correcting mechanisms will work. And to complicate it even more, and another reason why we should keep an open mind, is there are at least 4 different approaches to quantum computing, some of which being pursued by Microsoft include the kind of topological quantum computing, which arguably will bypass the error correcting risks, but could be longer out. So many possibilities are there. Anybody who tells you categorically they understand all the implications is smoking something here, but we should not rule it out. We should keep an open mind.
Right. Anyone else got a view around AI and quantum before we move on to the next question?
Yeah, I think it's really important, and I think quantum computing will be the linchpin in helping us get to AGI and superintelligence, because our brains are quantum computers, in my view.
Excellent. Okay, I'm going to throw out another question here that's been up for a while from Harsimran Singh, which is kind of a general one, but it sort of ties into what you've been talking about, David. Which industry do we think is most matured in its applications and use cases for AI? And then he's got a supplementary, which is, when are we expected to reach a full autonomy level in cars? So perhaps start with you on that one, Patrick, and then we'll close out with David on this.
Well, I think the industry that's most advanced is probably retail. We have applications both upstream and downstream in the retail industry. So all the stuff before the shop, and then the consumer behavior in the shop, whether it's online or physical. With autonomous driving, it really depends what you mean by that. There are 5 official levels of autonomy. You can purchase a car today that's mass produced that already reaches level 3, which is fairly good. There are quite good prototypes for level 4, and there's a kind of debate whether or not that might be a level 5 or not. So I would say, as far as prototypical cars go, in my personal opinion, they already exist and merely need to be phased into mass production. So what's the timeline until you yourself will be able to drive a car through the city that's driving itself? That is not at all far away. That's the next few years.
Thank you. Let's move on to your reflections on the polling question, David.
So they are slightly more optimistic on the whole than I am. I usually say there's a 50% chance we'll have AGI by 2050 and a 20% chance we'll have it by 2030. So the mode here is a bit more optimistic, 2025, and I'd be interested in what the basis for that is. I think there'll be many changes will happen, but none of the changes I listed by themselves will take us to AGI, probably. We'll probably need several things, and once we got there, we might need several more. But the reason I think 2030 is at least a possibility is because there are so many people keen to work on this field.
Maybe it's also that, you know, a number of you did a very good job in selling the idea that you could decouple AGI functionality from AGI being self-aware. And so we could see that functionality within 5 years. You know, I would say that there is already functionality on my phone that is smarter than me in particular domains. So if we scale that up, it's easy to see that we'll have tools that will have a portfolio of applications that basically end up being as smart as us on a range of things.
But let's be clear, if it's AGI would mean it could do all the things that we humans can do. In my view, that's what it means general. So it could be better at driving cars than we are. And it wouldn't need any special lanes. One thing that can help the advent of self-driving cars is if parts of cities are earmarked for them and without pesky pedestrians or other cars being allowed in, a bit like we protect the cyclists with cycle lanes. But to full AGI, it would mean that we wouldn't need any of these restrictions, and it's quite an ask.
Oh yeah, definitely, definitely. Anyone else got a quick reflection on those timescales before we move on to our final panel contribution? Okay. Well, let's take our fourth and final panel member, and we're going to change tack now slightly. We're going to dive deeper into the realms of AGI with Julia. Over to you, Julia.
Yeah, and also deeper, and also like 10,000 feet above, probably. So let's see if I can successfully. It says that host has disabled screen sharing. So can you make me the co-host so I can share slides?
Okay, so sorry, I thought you weren't going to share.
Oh, that was before the future happened.
Okay, there you go. You're co-hosting now. You have full power to share.
Thanks. So I want to talk about love because people get really embarrassed about love in academic and government and industry circles. So anything people are really embarrassed to talk about, I think there's something going on there. So let's first talk about popular images of AGIs. I'm going to show you some popular images and sort of like the ethos of several common ideas about what AGIs could bring, especially if they're embodied. Here we go. So one is AGIs as perpetual obedient children. So one way of controlling an intelligence that we don't totally understand or that is like our intelligence but that we're scared of is to not allow them to grow up, which if they're super intelligent eventually can read the entire internet, would make them perpetual obedient children who are smarter than us and would therefore be some sort of a victim to humanity because they couldn't grow and become independent of us. Then there's this model of AGIs as bad parents or perpetrators. So we have the perpetual child model, which doesn't work because that's the victim model. We have the AGIs as bad parents, robot overlords. So they're perpetrators. And, you know, I like to hope that our world is moving past the patriarchy and white supremacy and colonialist ideas that we've been working with for a long time. And so I'm hoping that there's this other model that we can learn into and explore, which are embodied AGIs or AGIs themselves without being embodied, although we could talk later about why embodiment might be important, as colleagues and teachers. These are the model, the human model is as friends and good parents. Here's a scene from Interstellar where this AGI embodied in a very strong and fast-moving machine cares enough about the human colleague that this AGI is going to save the human colleague in a way that the human colleague could not save him or herself. I forget what the gender of the person is. That's why I started the Loving Intelligent General AIs, or Loving AIs project. There's an article in Forbes about that. And I approached folks at, who are now at SingularityNet and Hanson Robotics about using the humanoid robot Sophia to create loving intelligent general AIs. So you can read more about that at the lovingai.org website. But we had a couple human robot, human avatar interactions that convinced us that there's something very useful going on here. And it's not like we came out of the project with AGI, but we learned a lot about how to help people feel loved. This is a slide that you might want to just take a screenshot of, because I don't want to read all this, but on your own time, if you're interested. The purpose of the slide is to let you know we actually created a definition of what human unconditional love is. It's essentially love for all that is without conditions, so it's not transactional. And the Loving AI version of unconditional love is operationalized for the Loving AI, and includes both, at first, helping people feel unconditionally loved, and hopefully over time actually helping the AI or the AGI feel unconditional love itself. So generally, people predict that when they're going to have an interaction with an embodied AGI or an embodied AI, they predict that they're going to have an uncomfortable or an unpleasant experience. And so this is a mock graph of what people predict and what you would expect to measure as a scientist. So in terms of the change from before to after a conversation with such a robot who was basically an embodied AGI or an embodied AI, you would expect an increase of heart rate and aroused mood, sort of agitated, signs of agitation, decrease in pleasant mood, decrease if you measure it in love for robots, decrease of loving feelings in general. But this is the flip side of what we found in 2 experiments. The change from before to after a 15 to 25-minute conversation with the robot that was running off of a chatbot and then later off of more sophisticated emotion detection neural network, we found a huge drop in heart rate, no change in arousal, increase in pleasant mood, increase in feeling of love for the robot, and increase in loving feelings in general. So there's something that was unexpected, or most people didn't expect about the interaction. And I think it had to do with the goal that was stated by the robot. And that was also our goal in the project. So why am I interested in focusing on unconditional love in AGIs at all? There's enough problems to solve with AGI. Why would you want to focus on unconditional love, which seems hard? So there's this hard problem of humanity, with a nod to David Chalmers, who talked about the hard problem of consciousness. I call the hard problem of humanity the human problem. We don't know how to be with ourselves or each other in a way that supports thriving for us and the planet. I'm just saying the obvious part out loud. We haven't gotten this figured out. It's why we keep buying stuff. It's why we keep doing things to try to make things better. I would like to solve this hard problem of humanity. And I think unconditional love, scaling that, is actually the solution. If we don't make, the other reason is if we don't make unconditional love central, if we don't make something as far out and as high-minded as unconditional love central, not only will it be ignored, but in our excitement, sometimes even ethics and basic compassion will be. So Yoshua Bengio, I think I'm pronouncing that right, not sure, just did a deep learning talk in MLSS 2020. A colleague pointed out to me, if you follow this link at the base, tinyurl.com/whylovingagis, it'll queue up to the last 2 minutes where after this really beautiful talk, he remembers, oh, I have slides about ethics. And he rushes through slides about ethics in about 30 seconds, talking about how nuclear disasters can happen and how we perhaps need to think about who has AI. I'm not pinpointing him as someone who doesn't think about that. Obviously he thinks about that, he had the slides, but it is so exciting and so fulfilling to our egos to think about how smart we'll be when we figure this out, that I think we forget that what we're doing is trying to improve the situation for the Earth and everyone on it. So I think of 3 models for how AGIs can actually help solve the human problem. So one is the SAGE model, which is where AGIs can detect levers for peace. So they can make associations that we can't make. They can bring together much more data than we can bring together. And they could actually detect strange and interesting levers for peace, environmental protection, and healing. For instance, an AGI might come after analyzing a bunch of data about human interactions and about the environment and say, well, it turns out you can use bioluminescent diatoms, and they are going to work perfectly together in a solar array to create a new energy source that's like 100 times more efficient than current solar or something, right? And then that's going to have this huge impact. So that's the SAGE model. I love that model. I think it's powerful. There's
2 minutes, Julia, to wrap up.
Thanks. Perfect. There's also this printing press model. So a printing press stores and replicates information for those who can understand in the future, even if everyone can't understand right now, which allows us to learn when we are able in the future. So basically training AGIs to be a repository for good ideas for humanity that can then be unleashed in the future. That's a neat idea. One of the ones I'm most partial to is the side effects or process model. In other words, it might be that in order to create AGI, we actually are forced to solve the human problem or the hard problem of humanity. So if we're the toddler with the scissors and we're creating a parent for ourselves to try to get us to drop the scissors or give it to the parent or do something responsible with the scissors, we have to be smart enough to know that the parent is being intelligent when they're telling us to get rid of the scissors. We aren't there yet. So I think AGIs might actually motivate us to solve the human problem in a way that simple parenting and the reality of what it is to be a human parent and a human child somehow isn't taken into account in terms of the seriousness of what we are doing on this planet. So this is my organization, loveandtime.org. You can check it out. And I want to thank Fast Future and UiPath and the Loving AI team, as well as the folks who support me. Thanks.
Thank you, Julia. Let's bring the other panelists in. If you could take your, yeah, excellent. Well, let's launch that was a fascinating little exploration of a much bigger topic, but I love this whole notion of, you know, really trying to think about unconditional love, not just as something that AI mimics, but actually something that AI helps generate in society. Can it become our teacher and model for us some of the most desirable behaviors? That would be fascinating. So let's take your question about what AGI might enable for us going forward. And while we're taking that question, let's go around the panel and take reflections. Let's start with you, Maria. We haven't heard from you in a while.
Yeah, I think it's a really impressive perspective, actually. I think if we have the capacity to generate compassion in human beings, we would solve, I think, most of the problems of the world. So yeah, I think we should collaborate. So maybe we can find a way to go in this path together. Yeah.
Cool. Patrick.
So first of all, I think unconditional love is super important, whether we're talking artificial intelligence or not. So we should try to develop that regardless. Honestly, as a mathematician and focused on the current applications of AI, I see this being far away from today. But if it is here, I think it's crucially important to make that general AI have feelings of emotions and ethics and so on, because definitely that overlord parent that's been in Hollywood movies would be a disaster. Whether we're able to create a loving parent that would have in fact some kind of control over us, but would do so benevolently, where is the dividing line between that and the overlord, I see as possibly difficult and dangerous. I see this kind of child AI as being more realistic in the medium term future, as a kind of servant at home doing menial tasks. That's probably a more accessible robotic application.
David.
So I completely agree that we need to go beyond the thinking which is prevalent in many technology presentations, which basically says that technology will make us stronger, more intelligent, more connected, and that will automatically solve all the problems of the world. On the contrary, we could be a lot stronger and more intelligent and more connected and just be more enabled to do nasty, unkind things to each other. We need, as well as the strength, we need the kindness, as well as the intelligence, we need the wisdom, and as well as the connections, we need the compassion. And I do agree that AI can have a role to help in developing these softer skills. There is anecdotal evidence about the Sophia robot that you mentioned from David Hansen, programmed with SingularityNet software, in which people were taught to meditate by Sophia and had a deeply moving experience. I don't think that stands up to peer reviews, but there are other AIs which are able to help people to deal with past traumas. They are able to keep an eye on the micro expressions on people's faces during interactions and know when to ask questions more deeply, as a very skilled therapist might, but these AIs can be even better. So I think there is steps forward there. I don't think this means that these AIs currently are really conscious. I just think they understand emotions pretty well at a certain level. In terms of models, I ought to mention one more model. It might lower the tone of this discussion, but let's put it on the table anyway. Intimate companion robots, or sex robots, which there is a growing interest in. And apparently the killer feature in sex robots is companionship. It's the ability of these robots to give the impression that they understand what people are saying and to respond emotionally and intellectually as well as physically. So, and I'll be remiss if I don't mention that the London Futurists does have an event coming up on Monday evening in which we have a session by a writer on that very field. And Julia, I'm sorry I didn't think of it beforehand. I should have invited you as a panelist to join that discussion. But I'm giving a big thumbs up to your project. Some other time we could talk about time travel as well. That would boggle the mind even more, I think, than AI is teaching us loving and kindness. But I think what you're doing is incredibly important, and I'm really glad we can have it on the table here tonight.
I think
yeah, you definitely don't want me on your sex robot panel, because I have a theory about that that's pretty controversial. So.
Let's take, just on that point, I think there's a divide, isn't there, in the research on sex robots, where men are looking for much more companionship, whereas women apparently seem to have a much simpler requirement, that they find the companionship through other models, but the robot, they're looking for a mono function, effectively. Let's take some of the questions that have been waiting patiently to be answered. From Robert Coombs, we hear, he asks, how can we ensure that AGI and ASI will work to ensure the betterment of mankind, as opposed to deciding that things would be better off without humans and eliminate or enslave us? Julia, do you want to have a go at that one?
Well, so if we teach them unconditional love, see, that's the point. So if you make that a priority, rather than we're going to do all these other things first and make them really smart, and then we'll maybe think about some emotions or some some ethics. If you make unconditional love a priority, not only are you going to get a bunch of really smart people trying to solve the human problem, which is what is unconditional love and how do we actually teach it and use it and bring it to mind when it is needed, but you're going to be able to create an AGI that actually uses it. So to me, it's the solution. I mean, it's like, and that kind of addresses what Patrick was saying previously is, well, if you can create a really good parent, it better be really good. So you don't get into this paternalism where it's like, well, I was really good before, but now, I'm going to tell you something else to do with that scissors. So yeah, I think unconditional love, understanding that really getting why that's a solution will allow us to move forward in that way.
Okay, let me ask you a follow-up question that comes from Diane Edwards. Can you share your thoughts on how the AI industry could deal with ethics, particularly when AGI is reached, given they are designed by humans who have their own innate biases?
Well, so that's the thing. We might actually be able to create something that doesn't have the same amount of bias that humans have, right? So that's one of the reasons why I think AGI might be promising, is it can be smarter than us. I mean, we have to let ourselves have some humility, and we have to let ourselves acknowledge our failures and see if we can build something that could help us with those failures, right? So it's about priorities. This is all human stuff. This is where are we going to put our priorities? What do we think is important? Is greed important? Is power and control of other people important? This is basically the problem. I grew up during the Cold War and read a lot about the creation of the atomic bomb, and it's very clear that when humanity is given technology that it can do lots of damage, we'll do it, and we'll also not do it, and it'll all depend on how we are with each other and how we are with ourselves. So this is an actual hard problem that needs solving. People think of it as soft, like David, when you said that couldn't pass peer review. Actually, it was presented by one of my mentees to an audience at NIPS, and they were peers, and they seemed to really like it, the actual data, not the anecdotal stories. So what do we want to spend our time doing on this planet?
Okay, let's close your part of the session with the polling results. And any surprises here in what you see, or we seem
from me? Yeah. People really are desperate right now for insights about how to heal people and the planet. We're starting to get it that we don't like the idea of a lot of people suffering. We're starting to get it that doesn't appeal, and we're getting sick of it. And so really matters to people that we don't know how to figure out this particular problem of how to live on this planet. It's the most remedial problem that any species needs to solve. How to get along with each other and how to live on the planet. And we don't have a solution for it that works yet. So yeah, no surprises there.
Okay, great. Right, so we're going to do a quick fire round of questions now. And I really plead with the panelists to stick to 1 minute for your answers so we can get as many in as possible and have a hard close at 8 o'clock. Let's start with you, Maria. We've got a question here from Harsiman Singh. He'd like to know about use cases of AI in fighting COVID-19 and how the UN is collaborating with corporates in this fight. Let's extend that to what role is the UN seeing in the use of AI in tackling COVID-19?
Sure, I think we saw a lot of applications. Well, not maybe a lot, but we saw some applications of AI to fight the COVID-19 pandemic, namely through predictions about the spread of the virus, developing of new drugs, and also AI also helped to develop some of the contact tracing apps, which can be a little bit controversial. But the position of UN, so I prefer to talk about the position of our center, So during the pandemic, I must say that we were more focused on mitigating the risks of the use of AI. So namely in the data privacy area. So we had a lot of work on giving recommendations on the best practices on how to use data that is coming from surveillance systems, contact tracing apps, and so on. So our perspective is that data should be always anonymized. The purpose should be limited. So if we are using this for a specific purpose that is contained the spread of the virus, so the entities that hold this data should not use it for other purposes, for health insurances and other industries. Yeah, and time limitation. So if after the pandemic, to make sure that governments will not should scale back their power of, yeah.
Thank you. I'm going to give a question to Patrick, but David, while I'm giving that, I'm going to allocate you Sadia Tariq's question, which is about a 9-part question. So if you could be reading that and framing your 1-minute answer while Patrick is answering, we'll move along smoothly. So Patrick, I'm going to table you the question from Samir Mehta, who says he's hearing a lot on the field of reinforcement learning, specifically linking to human behavior systems and ethical learning decision systems. Can you share your views on those things? So,
yeah, so reinforcement, sorry?
Yeah, so Karen.
Yeah, so reinforcement learning, of course, is a very nice technique. That's the technique that's resulted into programs like AlphaGo. So if you have a scenario where the rules of the game are extremely clear and the game is usually quite limited, so you're talking about chess, Go, games of that sort, reinforcement learning is absolutely fantastic. You start off with a computer that plays very poorly, but it very quickly discovers by trial and error where the poor moves are and where the good moves are, and eventually it becomes very good. So you can train a chess computer from a blank slate to absolute grandmaster in about 3 or 4 days of computer training time, which was unthinkable even 2 or 3 years ago. So that's an enormous achievement. So, but that's within the aspect of playing an artificial game. These techniques have been applied to sort of real life scenarios. They're a little harder because real life is a little more complex than chess or Go. And so there, these algorithms are more challenged. We're trying, or I've tried to apply these in industrial control. So if you're thinking of controlling a power plant or an oil and gas facility, it interacts with the human operator. You can use reinforcement learning to develop a better advanced control application for that process. So if the application, again, has a very narrow focus, this is an excellent technique.
Thank you. David, you have your challenge.
So Sadia is asking about combining AGI with other more narrow kinds of intelligence, including reasoning for particular domains and including emotional intelligence. Well, actually, all the models for achieving AGI work in that kind of way. They don't have a model in which this is the AGI, rather it is an architecture in which there are many parts of the reasoning which combine together, and somehow AGI emerges from the interaction. So if you look at what SingularityNet are doing, for example, they're very explicit that they are imagining the AGI will emerge at a higher level. Rather than there being a single module being the AGI module. After all, when you look inside the brain, I don't think you find a bit that is the human general intelligence. People still argue that there might be a way of looking at the brain holistically, and at a particular level of abstraction, you'll see the general intelligence, but rather it is a combination. So yes, Sadia, that is exactly the idea. And if you look at the AGI conference proceedings that took place in 2020, a couple of weeks ago, you will find exactly these architecture diagrams.
Okay, excellent. Thank you, David. Again, sticking to our 1 minute answers, Julia, we have a question from Pramod Kunju, who says, do you think the definition of consciousness will change the moment AI systems seem to have consciousness as we define it today?
Almost certainly, because that seems historically what happens is, you know, the definition of AI changes and the definition of AGI changes every time we get something, right? So, but I think that that's the wrong question. So I'm going to ask the other question that I think you want to ask, which is, what does consciousness have to do with AI? And I think there's this idea that if we make AIs conscious in the way that we're conscious, that's going to make them smart. I don't see the conscious mind as the smartest part of this, of the brain. I don't see conscious experience as the part that actually knows what's going on. I see the unconscious processing as the one that's actually in control of what our experience is and what we do. And I think that the moment we start thinking about AI differently like that and ask ourselves, is the unconscious mind the human that puts the data into, it puts the exemplars into the machine learning algorithm? Or is the conscious mind, the unconscious mind actually a subsectioned, cordoned off part of the AI that is different from the conscious part, which would be more what I see in the human brain and the human mind? I think we're going to start moving quickly towards interesting solutions. So there's a fetishizing of consciousness that I think is not worth it. Conscious mind is a story about what's happening, and it's not accurate generally. So,
okay, thank you. Right, we're going to do one last round of 30-second answers this time, so that we can definitely close on time. Question for you, Maria, from Tero Keski Valkama, who says, AI can be used for crime prevention, in effect to uphold the law better. Are there any concrete programs to use AI in governance, transparency, good governance, and fighting corruption?
Concrete programs. So I think the different agencies of UN are responsible for different matters. In our agency, we don't have a specific program for this, but I think there must exist someone responsible for doing that. Yeah.
Okay, let's go to you, Patrick. From R.A. Matthews, do you foresee any algorithm bias related issues in the future?
There are certainly bias issues and in the present moment, and they will keep on going in the near future. However, I see those biases, in every case I've encountered them, as being dataset biases and not biases of the algorithm. For example, facial recognition algorithms currently are far more efficient at Caucasian faces than at non-Caucasian faces. That is not the fault of the neural network, it's the fault of the dataset that was used to train them.
Okay, let's go to David with a question from Kunju again. Do you think there is an eagerness to tag everything as AI? The example of how much inventory is needed in which store is traditional analytics. Do you see any need for AI in that?
You're quite right. There's a lot of AI hyping. People have found out that sometimes they may get more interest in their data or their solution or their product. If they call it AI, they may get more investment. So there is a lot of hype unnecessarily in this field, which sort of spoils things. But that doesn't mean to say that there's no reality to AI. There is a great deal of amazing work being done.
Okay, and the final question to the panel comes to Julia from Cyrus Lurash, who says, what is your view on machines and emotions? Machines can have synthetic feelings and feel sorry to see us kicked by someone in the same way as we feel sorry to see a robot kicked by a human. Will they feel that in the same way as we do?
We don't even know how we feel that. And frankly, I don't even know if I felt that 5 seconds ago or if a person I'm talking to feels that. There's this problem of subjectivity and intersubjectivity that we haven't solved. So I think the solution that we're gonna have is we're gonna create embodied AGI so that we can at least feel that they feel similar things that we do. And that's what we do with humans too. We create babies and we have the experience that they're like us.
Thank you. Well, just leaves for me to close the session quickly. Thank you all for such excellent sharing of so many interesting ideas, some great presentations. I just want to close on what's coming next, to thank everyone for being part of the session as either a panelist or as a participant, and just to remind you what's coming next. So on Monday, we have two sessions going on. Firstly, I'll be running a talk on how do we rethink and rebuild the path to the future, drawing on our new book. I'm really exploring three areas: individual sustainability, corporate vibrancy, and government resilience. Then that afternoon, or later that evening, here in the UK, we have the session that David talked about, where Jenny Kleeman will be talking about her new book and addressing the theme that you can see on the screen. I don't need to read it to you, but that promises to be a really interesting conversation between Jenny, Gemma Milne, a tech and science writer, and myself, with David moderating. And then finally, just pushing out to July the 30th, we have a session on the future of financial services, where we'll have Brett King, Elaine Maddox from our sponsors UiPath, and a number of other really interesting people who have said they'd like to be involved. We're just trying to get diaries aligned. If you know particularly of women in this field who might be interested in being panel members, do let us know. We always try and have a global and gender balanced perspective to these things. And finally, just a reminder, I mentioned at the beginning, this series is sort of born out of the book that we published on June the 1st, where 25 different future thinkers from around the world came together, and in the space of just 10 weeks, we created this 28-chapter book, exploring different dimensions of how the future might play out as we navigate through and beyond the pandemic. So if you haven't bought your copy, shame on you. Anyway, so that's my thank you to everyone for coming. It's 8 o'clock now, time to release you all back to whatever it is you're about to do next. Thank you so much to the panel. Thank you to everyone who's taken part as a participant, who's shared comments in the chat, or who's raised one of the many, many questions we've had. And sorry to those who had questions that we didn't get around to answering, but we try as hard as we can. So thank you, and see you at one of our future events.
Thank you.
Bye-bye.
Thank you, bye.